Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 46 and we're continuing our discussion on concurrency. In this lesson, we're actually going to be diving into some of the code that we use to implement some of this stuff. But before I do that, I remind us of what we're attempting to accomplish by using something like threads in order to have concurrency and to do a bunch of things at once. In our situation, those bunches of things would be monitoring hosts, devices, and services. So we are going to be talking about threads, about thread pools, about async IO. We're going to look at code for threads and thread pool. In this example, we're going to look at the code that I've written to actually do it. We're going to run it. We're going to remind ourselves of the fact that I have actually implemented concurrency using thread pools in our Quokka application, and we will be looking at that in the next session. But this one, we're talking about threads and thread pools, how easy it is to implement stuff, and how it can be actually difficult if you look at the documentation on something like thread pools, and you might get discouraged, but never fear. I've given you an easy way to do it that works perfectly for our example. So hopefully this will be instructional and educational for you, and you'll come away from it with an ability and understanding of how to do simultaneous executions of polling of devices, making use of threads and thread pools. So let's get started. All right, so let's start talking about how we actually implement concurrency in Python. Now recall that what we're trying to accomplish is this. When we have a single thread, we go through monitoring of devices or hosts or services or whatever it is that we're doing one at a time. And so this can take a long time. You're subject to significant delays when you're attempting to talk to nodes that are down, and it's altogether a bad idea. What we would prefer to do is something like this. So in this picture here, you can see I've identified the fact that we're doing everything at once. So we're starting a bunch of threads, whether that be through threads or a thread pool, or we're doing asynchronous IO. We can also do something called multiprocessing, which is similar. The general idea is that we're doing everything at once, and so it's much quicker. The amount of work is the same, whether we do it slowly or over a period of time. It's effectively the same, but we are getting it done much quicker, and so our round trip time for getting stock of what's going on in the network via monitoring is much faster. So that's a good thing. We talked about those things. We talked a little bit about how with threads it's very good for IO-based concurrency in Python. If you don't do that, if you recall, if you're trying to do something that's not IO bound, then you can make your problem worse because of the Python Global Interpreter Lock, or GIL. But we're lucky because we're doing things in the network with a lot of wait time, and so this type of IO is perfect. We're going to look at using threads, where you manage threads manually. You start them and manage them manually. We'll talk about using a thread pool, which is an interesting idea that came up a while back, where there is a pool of threads that's available to be used, and these can do any amount of work that you assign to it. So we'll be assigning work to it. And then the third type that we're going to talk about is async IO, which is a relatively new introduction in Python. In this situation, we use only a single thread, but for IO, as the name implies, we do IO asynchronously, meaning we launch it and then at some point in time later, we kind of rendezvous or gather together all of those IOs that we've started and we complete them. And so those are the three types that we're going to be looking at in this session. Now I want you to see what's going on my screen as we're doing this recording. I have our little mini Quokka. I'm not sure whether to call it mini Quokka. It does do less than the real Quokka, but it is sort of a legitimate implementation, at least on the monitoring side of things. And we've got this going exactly as we did before. We're using Flask. You can see Flask is running, not here, but it's running somewhere in the background. Yeah, there's Flask running, and it's getting requests and satisfying those requests. We're storing information in the database. I'm using the Mongo database. I've come to like Mongo in the short time that I've been using it, so that is what we're doing there. So I've got all of this stuff going on. You'll notice if you were paying attention in the tweet, I added a few little augmentations. As you can see here, I am taking note of the response time, and if it doesn't meet the criteria that was set in the configuration for this particular service, then that changes to this cyan type color. I just closed my laptop, so if you see that go red while we're talking, then you'll know why. Bam, it just went red. Okay, and here my CB Asus laptop also went red. So you can see I'm monitoring, things are going on. What you will tend to see in these screens, in these displays, is that since I'm only monitoring periodically, and since monitoring goes way, way, way faster, as we're going to see in just a second, then the little incremental turning of light green 1 by 1 or 2 by 2 or 3 by 3 doesn't happen in the same way as it does with the previous versions, and so that's just to be expected. The last thing I'll note here is that I'm taking note of this version. As you can see, I'm not able to talk to this device here, and I'm actually printing this poorly, so I need to fix that. I must not have the version number of the model, and I'm not printing the appropriate number of spaces. So, but what you can see here is that I have highlighted this. This is an indication that this particular version is not meeting the criteria that I set for what the standard for this type of model of device should have as its OS version. And if you did notice just a second ago, these all turned green, and now they're back the bright green, and now they've turned back to the normal green because the polling happened so fast. So that's going on in the background. The last thing I want to point out is this, and I'm going to clear this away so that you're not distracted. This code over here that you see, I've written 3 example programs that, as we'll see when we look at the code, it's exactly the same code as we're using in the previous versions that I've done for pinging hosts. All I'm doing is I am using threads in order to do it. And so what I'm going to do here is I'm going to run host monitor threads. That's this one. That's the simplest, kind of the old school way of doing things where we manage everything by ourselves. I'm going to start this now. You'll have to believe me. You will see it in just a second. It takes about a half a minute round trip time to ping every device as I have done it prior to this concurrency lesson. Now you'll see that it goes a lot faster, and I'm going to do both of them here. So here I am starting my threads. You can see, bam, all 20 some of these finished, and now these 3 delinquent ones failed, and that took only 3.25 seconds. Now you can see I'm doing the same thing, not using threads. So this is to give you an indication of what goes on, kind of a visual representation of what has to happen in situations where you're not using concurrency. So what I'll end up doing is I will compare this time here, this time up here, with the time that it took. So it took about 30 seconds. So here's my comparison. Using threads took 3.24, not using threads 2.990. So you can see there's a big difference. That is basically an order of magnitude. That is me using threads. Now what I'm going to do next is I'm going to just run it using a thread pool, and by default my thread pool uses, I think, 8 different threads. So if you watch carefully, when I start it, you'll see, bam, I'll have like 8 responses or 7 responses. So let's take a look at this. So it's starting to ping, bam, we see about 8 responses. It does the next 8 or something, and you can see here it took 5.2 seconds. Why did it take longer than up there? Because I have less threads going. Up here I had a number of threads equal to the number of hosts. In this situation, I said I only want to use up 8 threads at a time. We'll look at the code that does that. And so it took a little bit longer. If I was to do this and say the thread pool size was 1, then it would go roughly the same speed as it does with going through them one at a time. And if I set it to something larger, as I'm about to do, then you'll see that it'll go faster. So remember this comparison, 5.21 versus 30.5. You'll notice this not using thread pool tends to vary a little bit, but let me go and run the version of this that sets the pool size. Let me widen this a little bit so you can see it. Here I have a parameter that will take the thread pool size, and so I'm going to set the thread pool size. I'm going to actually change that to 40, and we can watch how this runs. So now I've set my thread pool size to 40. You can see that everything that's known went really fast, and so you see my end time here is comparable to what it was when I started a single thread for every one, and that's because I am using a single thread for every one. And of course this will go the same rate of speed roughly for doing these one at a time. It'll be around the range of 30 or so seconds depending on what else might be going on my system. So this is about to finish. I think that's the last one. So yeah, now we're back to an order of magnitude difference, 3 seconds versus 30 seconds. So there you see me using thread pools. And now, and I'm going to show you this. I'm going to show you the code, so just have to be patient here. Now I'm using async IO. Now async IO is only going to use one thread, but what it's going to do, it's going to initiate all of the monitoring for all of the devices all at once. And so let's take a look at what happens here. I'm reading my devices. Bam, it's started all of those pings, and it's gotten all of them back. You can see it's basically the same amount of time taken as if I had done threads. And now we have to wait for the one at a time version. You can see how you can get pretty addicted to doing it fast. It makes your display here a little less cool because it doesn't. Did you see that? It turned them all green at once because it finishes them all at once, and then the next time it will be done, and so you'll see it'll all go green. It didn't used to do that. Maybe I'm the only one that noticed that. But here we see 3.3 versus 29, again roughly 30 seconds. So that is what the results are with my test example code. And the next thing we'll do is we'll actually look at the code. All right, so let's look at the actual code that makes this happen. Now I'm in M08 concurrency. I've created 3 different applications. One of them is host monitor threads, another is host monitor thread pool, and another is host monitor async IO. Why do I call it host monitor? Well, I basically took the exact code that was up here, host monitor, and I ended up using it as the basis for what I was going to do here. Now I'm not doing all of the things that I did there, but the fundamental thing, which is to monitor hosts, I am doing exactly the same thing. In fact, I have host monitor here from the previous lesson. I'm going to split this to the right, and we can look at ping host. And if you look at these two, they're basically the same. Now this one has some extra print statements going on. I have a print statement at the beginning there, but aside from that, I have my sub process to do a ping. I set my host availability and last heard, same exact thing as I'm doing right here. So this function called ping host is exactly the same as it is in this older version. So I did not have to change that at all. Let's look at the code that did change. Now I have written this so that it can do discovery if you want. I put discovery and the things for getting hosts and writing hosts into this thing called host common. If you're looking at the code, if you've pulled my code down online, we don't have to, well, I'll just pop it open. All it is it is a module which has get hosts in it, it has discovery in it, and it has update host. This is exactly the same code that we've always been using, so there's nothing new there, so we don't have to worry about that. So let's look at the main code and see what it does. Now this is the interesting code here where I'm doing my ping using threads. You can see down below I'm doing a ping one at a time where I just iterate through those. What does this ping using threads do? Well, basically I need to keep track of threads myself. This is something when you do it, and I'm going to keep calling it the old school way. It's not that it's old and people don't do it anymore. There's certainly reasons to do it. I do it in Quokka, but you do need to be aware of all of the thread objects that you end up creating. So that's what this thing is for. Now I go through all of my hosts, and for every host, I'm going to create a thread. See, I've imported the threading library, and for threading, I'm coming through and I'm saying capital THREAD. That gives you a clue that I'm creating an object of some type, and it's going to be of what type? It's going to be of type class. So it's going to be a thread object. And here's one of the cool things. There are two ways to create threads, two major ways. One is to define your own class, so do your own object-oriented stuff, and inherit from this thread object. Another way, the more simple way, and the way that's more probably pleasing to those of you who are not into object-oriented and not going down the whole full-fledged object-oriented path, is that all I need to do is create a thread object and pass in the code I want it to execute when it runs. What code do I want it to execute? I want it to execute ping host. And that is my actual function that I've defined right there. So I point my thread that I'm creating at this thing called ping host. Now PyCharm is going to want you to do this, and pay special attention. Everybody pay really good attention to this. PyCharm is going to want to put open and closing parentheses after your typing of ping underscore host. Why is that? Because PyCharm knows that it's a function, and if you want to call a function, then it needs to have these parentheses. However, that's not what I'm doing here, and pay attention for those of you that are new. This will be possibly a new thing for those of you that are intermediate and beyond. You need to be totally aware of this. You will make this error as I have done. What happens if I pass in this is it actually calls ping host, and it puts as target the thing that ping host returns, which, as you can see, it returns nothing. If, on the other hand, you just pass this in like this, then you're saying, oh, my target is actually a function. And that's what we want it to be. I'm passing in basically a reference to this function. That is what I need to do. So beware of this, all right? Write this down if you think that you'll be doing any amount of Python programming in the future. Make sure, and there will be other situations where you're asked to provide the name of the function. Make sure that you're passing in the actual function name and not putting the parentheses, which will cause it to get called. Okay, that's the first parameter, right? Everybody with me here? I'm creating my thread object. I'm passing in the target, which is the code that's going to run. What if I want to pass in parameters or arguments to it? You can see here, my ping host requires that a host be passed in. Here's another thing you need to pay special attention to. I can specify my arguments. You will be tempted to say, oh, well, my argument is, let's say, I'm going to just get rid of these parentheses. Why do I need that? And now I see, all right, well, I've got the comma there. It looks kind of weird. Why don't I just say pass in host? And it will be smart enough to be able to do this. And actually, it's not smart enough to do that. And Python would argue that it's actually smarter than you and that you shouldn't have done that in the first place. Let's look at what this is. What am I saying the arguments are? If I have these parentheses, what type of data structure is this when I define data that has parentheses around it? If you say tuple, you're correct. I'm passing in a tuple. And as you can see, kind of visually, that parameter lists are like a tuple, all right, in a certain sense. So it's like passing in this data. Now, I know technically, don't jump on my back, that it's not exactly what it is, but that's the general idea. So you need to have those parentheses there. The second thing is this. Do you see that comma? You will be tempted to do this. And what will it do when you do that? It will do exactly as if you didn't have these redundant parentheses, because it doesn't know that that is a tuple that I'm passing into the arguments. I need to have this comma, and now it knows, oh, this isn't just one thing in parentheses, it's actually a data type called a tuple. This is bonus good information for those of you that I haven't gone over this or haven't used packages that did this that much. So here embedded in our concurrency, you're getting to learn something different if you have not experienced this before. The examples that you see online will do this correctly, and so make sure that you don't say, oh, well, I can take a shortcut. I don't need those parentheses. In fact, you do. All right, so we've talked about what this is doing. It's creating a thread object. Now, at this point in time, I have a thread object. All right, it is doing absolutely nothing. I just have an object. I haven't actually started it running yet. What I'm going to do, and I could do these in any order, but what I happen to do is I take my ping thread object and I append it to my ping threads because I have to keep track of all of them. Remember, I am in charge of this, having to do this code right here. You'll see with thread pools, I'm not in charge of it, so I don't have to worry about that. In this situation, I need to make sure I keep track of these. So I add my newly created thread to this list of threads. And now I want to get the darn thing started. I've created it. It will do absolutely nothing until I tell it to start. When I say start, what is Python going to do? It knows that this is a thread. It's going to look up in the thread that I created, and it's going to say, what is the target code that I'm supposed to be executing? And it will say, ping host. Do I have a ping host? Yes, I do. That's where it is. Now, do I have any parameters? Yes, I do. Here's my list of parameters, and it gives me the list of parameters. And then it's starting it, so then it executes this. Now, you will have threads in your life if you go on to write more code that actually run forever. In fact, in Quokka, my monitoring thread that's in charge of all monitoring for hosts as well as the thread that I have for devices and for services, they run forever. In our situation, this is going to run to completion, so I know that it's going to end when it's done, because it's either going to succeed here or it's going to time out and fail, in which case it does this. In both cases, it ends. And what am I going to do? How do I end up waiting for these to actually complete? And the way that we wait for it is we have to iterate through these. And you may say, well, what if one of them finishes before the other? If I'm waiting for all of them, then that doesn't really matter. I'll have the same wait time by the time I'm done, whether the first one took 5 seconds and the next 20 took a third of a second. It's going to be the same whether this first one is slow or the last one is slow or whatever. So I'm just calling this function to wait till they complete. Now, Python does a lot of things that in my mind are great. So as I mentioned at the beginning, I came in as a skeptic of Python and even a Python non-liker, or a person who didn't like Python. I became a person who kind of likes Python, and so I enjoy it. One of the things Python could do better, in my opinion, is naming. They reuse things like they reuse init all over the place. They reuse this word join. If you recall from strings, there's a string function called join. Now what this join is going to do, really more descriptive for me, and there's probably a reason why they chose this, but basically I'm waiting until the thread finishes. So a join says wait till it finishes. So when you look at threading, if you're doing it manually by hand and managing the threads yourself, so you're going to see a start and you're going to see a join. And that is what's going to happen. So here I start all 20 some of these threads that are monitoring the host, and then I'm going to go through and I'm going to wait for every single one to complete. And then when it's done, let's see, here it is. Then when it's done, where's my threading? There's thread pool. Here's my using threads. When it's done, I'm going to write completed pinging of some number of hosts using the threads, and I calculate the time. And you can see right here, I calculate the time, and then I print out exactly that thing that we just looked at. It's going to print it out. So this starts all the threads, and then it waits for all of them to join. Now, when you look up threading, for threading, this is a pretty common thing that you will find online. When we get into thread pools and stuff, you'll find that my solution is way simpler than the ones that you see online, and I don't go into every single method that you can call or that you can use for doing thread pools, and that's probably okay because we're trying to keep it simple. But for threads, this is pretty simple. Let's look at the code that we do without it. Is exactly the same as what we did before, and then we print this out, and that is the result of what we have done. Remember, did we change our function that actually did the pinging? No, we did not. Did we change our main? Yes, we did. We came in, and for every one of our hosts, we created a thread. That's what this line does. Whoops. That's what this line does right here. We created the thread. We're keeping track of it, so we had to append it, and then we started it. That got them all going. I go bam for all 20 of these, or whatever the number is, and then I go and I wait for all of them to complete. That is threading in a nutshell. Now, the last thing that I'll mention is this works great in my situation because I have 23 hosts. If you're in charge of 10,023 hosts, doing a single thread for every one, while it may be the most efficient way to do things, and while in the future versions of Linux and different hardware implementations of your compute functionality may be able to handle tens of thousands of threads without batting an eyelash, but there are limits in the world of Ubuntu that I'm running in, and you can run into issues with that. And so when you have that situation, or if you just want to make things a little bit simpler, then you may look at thread pool, and that's what we're going to look at next. Okay, let's get started talking about thread pools. Now, as I mentioned, thread pools, at least the way that I am going to be using them and describing them, can be much easier and simpler to deal with than threads, because if you recall in our thread situation, we had to manage the threads in terms of starting each one individually and then waiting for them all to finish. With thread pools, that is not necessarily so, but before you jump up and down and scream in joy and elation, I do want to warn you that if you were to go online and to look up, okay, let's see what's going on with thread pools, and you start looking like at the Python documentation or whatever, then you will, if you're like me, you may be underwhelmed would be a diplomatic way of putting it. This documentation doesn't really even tell me what I want to know, and then I end up going to different places where, after Googling for information on thread pool executors and things of that nature, I find lots of hits, but most of the examples are more confusing than I wish they were. So just be aware of that and enjoy the simple example that I will be giving you, and maybe if you have need, then you can go into more detail with the documentation that I mentioned. But I just wanted to prepare you in case you do dive into the documentation in joy and find out that it's more confusing than you thought. But we are going to look at this. First, I wanted to show you really quickly. The thing about a thread pool is the pool. And so what I did in my host monitor thread pool is I have a parameter that you can pass in called pool size. If you set it to something like 40, that means there will be 40 threads that are available for running our applications. As you can see, I've cleaned up the output a little bit as well, that it says that the thread pool size was 40 and our time was 3.3. And now we need to wait for this to get done. Since there are 40 threads, you would expect the time to be roughly similar to if we created all of our threads manually, and indeed it was. I think it was in the around 3 or 3.2. I've been running everything, so we have more. No, we have the same number of hosts, so yeah. Anyway, that's the general idea. 32 seconds for the regular one, and here you can see that we're looking at 3 versus 30 in terms of the time that it takes. Now, thread pool size is going to matter. If I were to make this much smaller, like if I was to set it down to 4, let's say, so I only have 4 threads, it's going to be faster, as you'll see, but it's not going to be near as fast as 3.3 seconds. I think the times that I've run this, it is taking close to 10 seconds to complete it. And there, yeah, you can see it's 9.16 seconds in order to complete with a thread pool size of 4 this time. And of course, the one where I'm creating, doing my pings by hand. Not sure if I explained that correctly in the previous one, but the second thing was that we were going through was looking at them when they were all done sequentially. Sorry if I misspoke there. Sorry if I forgot, and I did speak correctly, but I just can't remember. But here you see the difference is only, it's like a third of the time. So your thread pool size is going to matter. So let's look at the code that actually implements this. And as I mentioned, there are multiple ways to do this. If you do go to the documentation, you will see that there are multiple ways both to launch your threads within a thread pool, and they behave quite differently from one another. And there are multiple ways to gather or collect them, wait for them to finish. And so you can see that when you go through this, if you want to go through this on your own, or you could say, you know what, our example fits perfectly with this easy way to do things, and so I'm going to stick with that. So what do you have to do in order to get it to work? Remember, our ping host is exactly the same as it was for our original version and as it is for host monitor threads. Our main application, again, as we compared it with our host monitor threads, here I had to create and manage them on my own. In my situation, the easiest way to do this is to just using a with makes it a little bit easier. With thread pool executor, so I'm creating a thread pool executor. I am passing in the thread pool size as the max number of workers. I'm going to call it executor, so that's what this with statement, we've seen this before in examples that I've given. If you're newer to Python, then just remind yourself that this is what it is. Basically, it's saying do this, and then with the thing that creates, call it this thing. So our thing called executor, what I'm going to do is I'm going to say executor.map, and map is a function that I should probably take a minute and explain to you. More recently, like in the last, 10 years or so, it's been popular to have a new function in programming languages for iterating over a collection of items. And the general idea with map functionality is that you pass in a function that you want it to call, and then you pass in here what is going to be a list, and it will, this map functionality, and I'm speaking in general, it will execute this function for every single one of these items in the list. Now, host.values is going to give me, basically, it's going to change my dictionary of all of the host dictionaries. It's going to change that into a list of all the host dictionary values. So it's ignoring the key. We know that the key is part of the host. I think it's called the host name in my host. And so basically it's going to just pass that host dictionary to ping host as many times as there are hosts. So I'm doing get hosts again, and that returns the dictionary of all of my hosts, with the keys being the host name. And this is just changing that dictionary of host name, key, and host values into just a list of host values. And so what it's going to do, it is going to call ping host, and it's going to call it on a separate thread for every one of these. This is what my thread pool executor.map is going to do. It's if you have 40 different threads in my thread pool size, then I will have enough so that I instantaneously start 40 of these executions of ping host going at once. Each one has its own host. If I have 4 of them, then it will start 4, and when one of them finishes, it will pull the next one off and it will start that one. And when the next one finishes, it will pull that one off and start this one, etc., etc. I know I haven't gone into a lot of detail about the idea of thread pools and how these pool type patterns work, but that's the general idea. Like I mentioned before, it's a little bit like lines in a maybe in a supermarket or in a home improvement store where they have one queue and they send you to the first open checker or person who's taking your money. And that's the same idea with a thread pool executor. So as soon as when it starts, it launches 4 of these, and as soon as one is done, it pulls the next one off of its own queue and launches it on its own thread. And that's what it does. Now, as it turns out, and I never found this anywhere in the documentation, and I admit to not spending hours on reading the documentation. I probably spent maybe a total of the last few days of something like an hour, but I did try to find examples like mine, and I didn't find it. But here's the important thing. The question is, and here let's refer back to this. What did I do? I started the thread, and then if I wanted to wait till it was done, I had to later do a join. And here I just iterate through all the threads and do a join for every one. With thread pool, when I call map, it is going to both get the thread ready, and it's going to give this unit of work, which is going to be my executable, and the parameter it's going to pass in, which will be a host. It's going to execute that. And by the time you get to this statement here, all of your threads will have completed. Now, if you go to the documentation, there are many ways to check on completion of threads and to figure out who's finished and in what order, etc. In my situation, in our situation, we don't care because we know that this is going to complete just like we did before with the host monitor threads. We know that our ping is going to complete in some way, shape, or form. It will either succeed and we will have a successful ping, and we can set availability to true and set the last heard value, what I'm doing right here, or it will throw an exception because it failed, and at whatever happens, either one of those cases, it's going to end up completing, and the same is true for us. It's going to complete after some number of seconds. And if we look here, we can see that in our example, this one had only the 4 threads, so you see some of these failures interleaved. If I go all the way back up here, when I had 40, you can see there was time for all of the successful pings to succeed, and then at some point in time later, then all the failures came in. So basically, and that's when I printed out this line. If I look at my thread pool code and I say, what is actually the next line that's going to happen? And the next line is I calculate the time, and then I print it out. My print statement got to be too long to be just one line, so it basically looks like this, but this is what my print statement actually looks like. And probably if I was to run my program, it would make it look like this. No harm done here. It's just too long for one line of code, so I have multiple F strings. But that's that line. Completed pinging some number of hosts using thread pool size equals blah, blah, blah. That's basically what this is right here. And when I had only 4 items, 4 workers in my thread pool, then this is what this printed out. So as you can see, this is an extremely easy way to do monitoring in our world. We don't have to worry about threading, dealing with them on our own. We don't have to worry about the maximum number of threads exceeding that. We can just set an appropriate thread pool size, and we will end up with a far improved solution. This solution right here is probably the best example. You'd want to have at least 40 threads going on to do this, and we get an order of magnitude faster results when we do that. So not a whole lot to talk about. I contemplated showing you different ways that you can do this, but my goal, as I said, is to keep everything as simple as possible, but no simpler. And for me, this is as simple as possible, as simple as it gets. all you need to do is something like this. If you're more interested in different ways of doing threads, you can certainly look those up. You can contact me. I haven't had opportunity in Python to use all of the different ways that they explain in Python, but I can look into it for you if that is extremely important to you. But hopefully I'm right in thinking, okay, well, this is like so simple and easy to do. And as I mentioned, if I was to just pull this stuff up here, let's see what we've got going. We've got that one, and we've got this one, and we've got this one. These things are actually all using threadpool in order to make the things happen the way that we wanted them to happen. And so it's kind of a nice to be able to so easily improve the stuff the way that we were doing it, so that it is able to very quickly and efficiently ping everything that it needs to ping and be done with it. So there you go. That is threadpools. I suspect this will be all that we talk about for this lesson. And the next lesson I will talk about async IO and this implementation here so that you can see that I've done it. I'll point this out to you. If you were, if I was to look at our project and we were to see that, okay, well, this is what I'm talking about here. What about the one, this stuff running here that actually is doing it in my Quokka implementation? Well, I pulled the M07 Flask Mongo Quokka in common. I put it all into this directory here. So you can see this directory has all of this new code, and I modified my monitors so that my host monitor and my service monitor and my device monitor all use threadpools, and that's what I will talk about too. But that will be next time, I believe. Hopefully this made sense. And yeah, that's using threadpools. Okay, folks, let's review what we talked about in this lesson. We talked about how we want to go from this, doing things one at a time with respect to our networking devices, to this, where we're doing things all at once. And our means for doing this are threading as well as async IO. There's also multiprocessing in my code. I've implemented threads, threadpool, and async IO. They're basically going to have similar results. Threads is kind of an old school way of doing things where you manage them yourselves with a thread pool. If you do it in the simple way that I did, you can actually make it much easier, and it does help you in situations where you want to do more things than you have threads, so you use a thread pool in order to do that. And as we've mentioned before, async IO does something similar, but it uses IO asynchronicity methods, and you are no longer required to use individual threads in order to do that. We looked at the fact that, hey, I've already implemented this in our Quokka implementation that we've been going through in this class, so I actually have that going on. I added a few nice things for looking at the fact that we have devices that have open ports, etc. Then we began to look at the code, and we saw that we have basically this concurrency code. I have two different packages. One of them is the stuff that we're going through actually: host monitor threads, host monitor threadpool, host monitor async IO, and this complete implementation of our little Quokka application that I modified to use threads. And so we began to look at the different code. We saw how with threads you create a thread and then you point it at the actual definition of the application. Remember, don't put your parentheses here, and don't modify the way that we specify the arguments that from what I've done, because it won't do them appropriately, or you can get into those situations when you're doing them yourself. When you're creating threads on your own, you need to do a start, and then for all of the threads as well, you need to join in order to wait for them all to be done. In a thread pool situation, in the way that I did it, it's very simple. You just pass in the thread pool size to your thread pool executor, and then you use that executor object that you created, and you do a dot map, and you pass in again a reference to the function that you're going to use for executing the code. And then because you're using map, this is something that we do. You pass in a list of the the actual values that you want to apply to that. So for every one of these hosts, it's going to create a thread up to the thread pool size limit, and it's going to execute those concurrently. And then every time a thread becomes available, it puts the next host onto that code and executes it. And we looked at the output for that and saw that we're getting roughly 10x with our little 20 to 30 node network that we are pinging for. I did mention that you need to beware if you do look up different options for doing thread pools. You will find that there are many other options, and a lot of the examples can be pretty confusing. I would just want to console you that you don't need to be disappointed or discouraged when you see that there are simple ways to do it, and this is one such simple way to do it. And we did mention, let's see if I can find it here, the actual code that was running our application. We saw that in this situation with the thread pool, where we were using how many thread pool size was 40, and we ended up taking only 3.3 seconds instead of 32 seconds. And I think we specified a pool size of 4, and we saw that it took 9 seconds, so that's roughly 1/3 of the time. So even using only 4 threads sped up our time by 3x, I guess you'd call that. Anyway, that's what we talked about. Hopefully that makes sense. Next time we will come back and we'll talk about, if I can pull this up here, we will talk about async IO, and then we'll also look at my implementation. So yeah, hopefully that makes sense and you now feel empowered and able to do threads should you choose to do so. As always, if you have questions, please let me know by whatever means necessary. And yeah, thanks for listening.